In the previous video, we solved an exponential equation 9 to the x equals 81. What we did was to rewrite the right-hand side and 81 as 9 squared, and because the base are the same, and that tells us the exponents must be the same. So we got x equals 2. Now, there's another way to write it. So whenever we try to look for the exponent, so this equation I actually can introduce a new symbol, which is a logarithm, a new operation, logarithm. And we take the first three letters and we write it as log, and the base will be taking the same base as the in the equation, which is 9, and the x that, and then we take the right side number 81 and then put it right here. So we have this expression, which is called a logarithm, and that is looking for the exponent x. So this is how we rewrite this exponential equation as a logarithm. And so when we look for x here, we're going to do exactly the same way like we did. We keep the log and the base 9, and we just rewrite 81 as 9 squared. And then that if we have the matching base like we've seen here, and we have the matching base 9 and 9, which tells us the exponents x and 2 must be equal. And so that tells me, because this base matches, so that base is actually the base of 9 on the left hand side, and the second base is the base of the other number that we rewrite. So now we can get the answer that is equal to 2. So whenever we see expression log base 981, it's like asking us 9 to which exponent equals 81. It's just a different way of writing the exponential equation. So this gives us a new type of operation, which is logarithm. So the first type of question we're going to learn in this section, we are going to learn how to switch between the exponential equation and the logarithmic form. So we can look at the examples here. For example, if we have 6 squared equals 36, how do we change it to the logarithmic form? So we write down log, and the base of the exponential form will be the same. We keep the base 6. But instead, we're not going to put the exponent there. We're going to put the right-hand side number right here. And the exponent will be equal to 2. So when we look at it, it's sort of like the base 6 squared equals 36. And similarly, we can convert the others. So log with the base 10 and over 100 will be equal to the exponent 1. The right-hand side is going to be the exponent of the exponential form. And the base of the log is going to be the same as the base of the exponential form. All right, so we can convert the next equation. Base is 2, and the right-hand side number is 1 over 32, and the exponent would be the answer negative 5. So that tells us 10 to the first equal, I'm sorry, that should be 10 squared. 2 here. 10 squared is equal to 100, and this one tells us 2 to negative 5 equals 1 over 32. That should be, that's a typo there, so that should be a 2 there. And similarly, the last one, we're going to convert log base 10 and 0.1 is going to be equal to negative 1. Again, because base 10 to negative 1, when we rewrite it, 10 to negative 1 is going to be equal to 1 over 10. 1 over 10 is equal to 0.1. Okay, so that's how we convert an exponential form to logarithmic form. And we can, if we are given a logarithmic form, how do we convert it back to the exponential form? So we're going to follow the definition. So the base is 3, the same base, but the exponent will be the right-hand side number. So 3 to the 4th is going to be equal to the number 81. And the same thing here, we take the base 2 and we put the right side number as our exponent, which is equal to 1 over 128. And the last one will be base 10 raised to negative fifth equals 0.00001. Okay, so right here we didn't have to do any calculation for these types of questions. All we had to do was to convert between the exponential form and the logarithmic form. Okay, so now, so we're trying to do this exercise to get us ready, be familiar with the logarithmic form. Now, so we can evaluate these logarithms. Now, the first one, if you remember the definition, this means 2 to which exponent? So that whenever we see logarithm, we're looking for the exponent of the exponential form. So this is like solving equation 2 to which exponent equals 16. So following the way of solving exponential equations in the previous video, so what we do is we can rewrite 16 as 2 to some exponent. So it's like asking us 16 is multiplying how many copies of 2. So we can rewrite 16 as 2 to the fourth. So that tells us, okay, so 16 is actually 4 copies of 2, multiplying 4 copies of 2. So again, it's 2 to the fourth equals 2 to the fourth. Now we can do the same thing with the others. We rewrite 243 as 3 to which exponent? So we can, from the previous examples, we know 3 to the fifth, which is 3 times 3 times 3 times 3. Again, you can use a calculator to verify that. So that's 81. When we multiply 4 copies of 3, that's 81. So multiply another one, that gives 243. So that tells us, okay, 243 is equal to 3 to the fifth. So the answer will be equal to 5. Okay, again, because the logarithm is asking 243 is how many copies of 3? So again, it's 5 copies of 3. It's multiplying 5 copies of 3. So now we can work on the next one. And for the radical, we got to use something we learned before. So, and radical means 3 to the 1/4. Okay, so that 3 to the 3 doesn't have exponent, which means 3 to the first. So the exponent stays as the top, and this index becomes the denominator of this fraction. So we can rewrite 4th root of 3 as 3 to the 1/4. So the answer will be 1/4. Again, logarithm is looking for the exponent with the same base. So 3 to the 1/4 equals 3 to the 1/4. Or in other words, 4th root of 3 is actually 1/4, 3 raised to 1/4. Now for the next question, we rewrite 8, but actually 8 can be written as 8 to the first. So the exponent is 1. So again, 80 is 1 copy of 8. And for the next one, now we're going to rewrite this as a division. It's going to be 1 divided by, or actually we could use the 1 divided by, so we can 1, 2, 3, 4, and 5. So 1 divided by 100,000, which can be written as 1 over 10 to the fifth, and or 10 to negative 5. So this is something similar to the section we did before, the scientific notation, which was given as bonus question, but that's the same idea. So 0.00001 can be, you can move the decimal point 1, 2, 3, 4, 5 times. So that is equal to 1 times 10 to the negative fifth. We can rewrite the decimal as 10 to the negative fifth. Now, take the exponent of that. So again, it's asking us 0.00001 is the exponent of what exponent of 10? So apparently it's a negative fifth of base 10. Okay, so the last type of question is solve a logarithmic equation. So again, when we do this type of question, we apply the definition. So we can convert this to exponential form because we are more familiar with the exponential form than the logarithmic form. So we rewrite this 3 to the 5th equals 8 and equals x. So that tells us what x is, and we just need to work out 3 to the 5th from the previous examples. We know it's 243. So that just tells us x equals 243. And similarly, we can change this form, the logarithmic form, to exponential form. And we get x immediately, but we do need to simplify the left-hand side. And that's a topic we also learned before. And to do this, we rewrite the bottom, 27, the base as 3 to the 3rd. And keeping the exponent, let me use a different color for the original exponent. So what I did was to rewrite 27 as 3 cubed and keeping the original exponent. And now we can use one of the formulas of the laws of exponents. It's exactly the power of power. If you remember the formula, the power of power is equal to the product of the powers. So we are going to multiply 3 and negative 4/3, put a 1 underneath, and we can cancel the top 3 and the bottom 3. So that gives us the exponent can be simplified to 3 to negative 4 because these two 3's are canceled out. So we're going to have multiply straight across. The top will be negative 4, the bottom will be 1. And negative 4 divided by 1 is still negative 4. And we can use the definition of negative exponents to simplify this further. And we know 3 to negative 4 means 1 over the reciprocal. Again, this negative exponent means reciprocal. So it means 3 to the 4th and take the reciprocal. So I put 1 over 3 to the 4th, and we know 3 to the 4th is 81. So that tells us x equals 1 over 81.